We are Team 2, and this is our interim presentation on our analysis and redesign of a paint gun. A paint gun uses compressed air to spray particles of paint, atomized with air to cover large areas in short amount of time while leaving a nice finish. Our primary customers are commercial painters who need to paint a large area in a low amount of time while still leaving a nice finish. Our secondary customers are non-professionals who need to occasionally paint large surfaces, but in a way that is also affordable and easy to use. Our annual estimated demand is 310,000 units, and our estimated production volume is 75,000 units.
Here we see a isometric view of the fully assembled CAD. This is a diagram of our exploded view, including labels with an accompanying table with part count and description.
And this is our fast diagram for the paint gun, with the most basic function being to spray paint. A second layer of functions includes direct paint, store paint, atomized paint, transport spray, assure dependability, assure convenience, please senses, and enhance the product. Some other functions branching from those are to aim spray, regulate spread, pressurize paint, receive air, regulate airflow, mix air, prevent leaks, allow grip, minimize fatigue, enhance portability, and to apply the paint evenly.
This is our fishbone diagram where we are proposing two different types of assembly. In first assembly, main body comes in and the external nozzle, internal nozzle, sub-assembly gets fitted, followed by hanger, axle, washer, and trigger gets fitted, and those are secured by the snap ring. And then the adjustment knob and the needle sub-assembly comes in, and finally the pen cup got secured into the assembly. Our second proposal comes with the main body, to which the adjustment knob and the needle gets fitted, and after that the hanger, axle, washer, and trigger comes into the assembly and secured by the snap ring, and then the finally sub-assembly of the internal and external nozzle gets fitted, and finally the pen cup gets fitted into the assembly, which gives a better assembly sequence. Next one. In this chart, it shows the assembly sequence analysis, where the second sequence gives the more ease for the assembly, and it gives ease for like every mentioned criteria. So second sequence is preferred. Next.
And this is our functional component mapping matrix. Most parts are associated with the functive from the fast diagram, besides the fasteners listed at the bottom. You can see potential for grouping. For example, the external and internal nozzle are both used to aim the spray, regulate its spread, and ensure the paint is being applied evenly.
This slide shows the paint sprayer's bill of materials. As can be seen, the paint sprayer consists of parts made using injection molding, die casting, extrusion, sheet forming, machining, as well as purchased fasteners. The total unit cost of the assembly is $7.34. Therefore, our product is at the lower end of the market range from $12 to $100. Our paint sprayer sits at approximately 60% of this range, making it a cheap option.
This is our quad chart comparing our manufacturing costs to the functional importance of each item. The hanger is in the low functional importance and low manufacturing cost, so can potentially be eliminated. And the parts that can be changed are the external nozzle and main body and paint cup.
These are our two variants. So first variant comes with the paint cup, which allows us for the limited amount of the paint secured into the system. But in the second variant, we have given a tube which gets fitted to the paint tank, which will give us a continuous flow of the paint. And the second change is that we have given a V-shaped orifice, which is again a removable, so we can attach different kind of orifice according to our use, and it will give us different shapes of the paint. Yeah.
With these altercations in mind for primary and secondary customers, we now move to the product family design. On the left, we have the functional differentiation table. We have decided to alter two functions for these different customer groups. one being how the spread is regulated, and the other being the means in which the paint is stored. This gives the customer increased options as to how they want to distribute the paint and how much paint they want to use during operation. The component commonality table on the right shows how we would do this. By having a module system for the external nozzle, as well as allowing for the swapping of the paint cup for a hose system, we give the customer this variability in usage. Given these new variants, we were also tasked with modifying the assembly sequence to save time and money during manufacturing. By adding the external nozzle and the paint cup or hose at the end of the assembly sequence, we are able to get rid of unnecessary branching in the assembly process so that variations are assembled at the end, which saves time, money, and decreases the complexity of assembly. Thank you for watching Team 2's interim presentation for the paint gun.